Hi, everybody. Yeah, this is for my Monday crew. Sorry I'm missing, but we're going to put that video right here, and you can watch that with earbuds in class and do this assignment. And then, yes, we have a factoring review. I can't believe I got some people that still can't factor. Oh my gosh, it's driving me absolutely nuts at this point. Okay, but anyway, do the best we can here. Oh, getting text from my wife here. I got to hurry up and get these notes done. And I am going to fly through this because and this is Mrs. Fasola's notes again, and I'm gonna highlight the best parts of it, not short change it or shorten it up here compared to a major explanation. We kind of talked about this stuff here um, um, in our notes Thursday and Friday, and I kind of stuck here. There we go. It's just not moving. There we go. So vocabulary, nth root, radical symbol, radicand, index, rational exponent. These are all things that we are going to be talking about. First thing we got to be able to do is like we talked about in class. Square root of 4, of course, is 2. Negative square root of 4, that is not an I number. That's square root of 4, which is 2, and then you slap a negative on it. You should know that the square root of 2 squared is a free 2. These are opposite operations. And anyway, 2 squared is 4, so that should make sense completely. All right, you've been taught I numbers. So one of two things may happen in this book. They may say not real because they don't want to keep it real, or you could say this is finally 2I, and I really prefer that probably right now. Just beware if they show answers and say not a real answer, then that's why they're just trying to say only real answers today. But that's where you get an I, not number letter B. Cube root of 8, come on, after Thursday, Friday, that's 2. And then this is negative 2. Cube root of 8 is 2, and then you slap a negative on it. This is also negative 2, though. This is not I. This is negative 2 times negative 2 times negative 2. So that's what this index, there's your vocab word, index, tells you how many times a number is times itself. And then again, opposite operations, so do be aware of that. Cube root of 2 cubed is a free 2. Observations, conclusions, we already did it. I'm moving on. Okay, so nth root. So whatever this index is, so you're asking yourself what number times itself the index n times equals a. That's what this question is down here. That's what a square root is, or a radical question is. So why is there nothing with a square root? That's the default. The default is that index is a 2 there. There's a lot of things that are invisible in math, like x. What does x equal? X to the what power? And the answer is not 0, it's 1. But we just don't write it because it's just not necessary. We assume it. So we assume square root, that's a 2 there for the index. What number times itself twice equals the number on the inside? Really hope you can get this understood. And then how does this turn into a rational exponent? A raised to the 1 over n power. And this may come out of left field, but I'll show this on the calculator. And it is true, right? And you're going to have to memorize this because it does toggle back and forth with a couple questions pertaining to that. I just get tickles in my throat. Blah, blah, blah. Sorry for that. Okay, so let's not do square root of 4, like square root of 16. Boom, we all know that that's 4. So let's do 16 carat delicious to the 1 divided by 2 power, because that's what I just said, this new thing from Mr. Samulus. What? 16 to the 1/2 power, so 16's raised to the first, and then it's square rooted, and the 2 goes down in the bottom of that fraction. Ready, hit, set, enter. Boom. Yes, so that means the square root of 4. And I think that's all I want to show you. You sometimes just got to take a leap of faith with your teacher and then tell yourself, okay, I'm going to get this memorized. And that's your job. All right. So determine the specific roots of each number. Whatever. Like, what's the fourth root of 81? What number times itself 4 times equals 81? Use your fingers. 3. 3 times 3 is 9. 3 times 9 is 27. 3 times 27 is 81. So the fourth root of 81 equals 3. Cube root of 64 is not 8. That's the square root. What number times what number times what number equals 64? And the answer is 4. 4 times 4 is 16. 4 times 16 is 64. We actually had this in Friday's classes. I did graph fourth roots and fifth roots, which are the same as cube roots and square roots. Reverse that order there. What number times itself 5 times equals 32? 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. 2. The fourth root of 16, 2, not 4. Cube root of 125, 5. Ooh, the fifth root of 343. 4 threes multiplied together is 81. Guess what 3 times 81 is? So the fifth root of 243 is also 3. Ooh, let's do that fractional exponent thing. 243, delicious carrots. Fraction. I was trying to get the fraction button here. And then 1, 1, 1 divided by 5. That is the fifth root of 243. Boom, a shakalaka. I will also show you the X root button. We're going to do the fifth root thing, so we have to do 5 first. Second, square root. Wrong. Clear. I made a mistake there. 5, math. And then 5, that's the X root button. Watch what happens. Turns it into a fifth root. If you have an older calculator, it just says 5 X roots. And then you can do the fifth root of 243 on your calculator. Boom, shakalaka, same thing. Okay, so toggling a lot of different things there. This is no calculator. I could teach Lexi Samuels to type this on the calculator, press enter, and she has no clue what just happened. All right, that's an exponent button, Lexi. So type the caret. And some of you guys are just at that functional level, and you just got to stop. Okay, you got to stop and understand that you need to figure out the stuff. You can't do cheap tricks and shortcuts and cheat or whatever it is. Just write down the answers from the keys that the teacher supplies. Whole bunch of garbage going on with some of the students here not doing what they're supposed to be doing. Just drives me crazy. Some of you just laugh about it though. All right. That means the square root of 36. So that is 6. So 36 to the first power, square root of it, turning an exponential function into a radical. This means the cube root of 8 squared. You're not going to square 8 first. You're going to cube root 8 first and get 2. Then square 2 and get 4. We love these no calculator questions, and they will certainly be on some no calculator part of a quiz coming up in the future. This most certainly is not a no calculator situation. So you would just type that in your calculator. You have two choices. You can rewrite it as a fractional exponent and type it, or find the X root button and type it. But this is a calc. This is no calc. And you will be assessed that way, exercising the exponential rules that I have played out here. Really irritated. Scratchy. Square root of 25, 5, no time. It drives me nuts when people put 12.5. That's just a non-thinker. Doesn't say 25 times a half. This is the square root of 25 raised to the first. And that means 5. Ooh, baby, I love this one. Fifth root of 32 squared. And yes, you want to do fifth rooting first. You want to bring it down, then square it. You have choices. You could square 32 first. Why would I do that to you? These are the people that don't listen. These are the people that make their lives miserable in my, like in the math class. They make things harder on themselves. So fifth root of 32, you bring it down to 2 and evaluate that. Then you do 2 squared. So again, then these are also the ones, I just hit my mic there. Hopefully that woke you up. Not learning factoring still. Well, then that's why you're going to solving quadratics are always going to be a problem for you. Not doing those quick and easy things. Now, negative fourth root. That is not part of this exponent. So that negative is separate and left alone on the outside. 16 cubed. So do I want you to cube 16 first without a calculator? Well, if you do that, you're your own worst enemy. The fourth root of 16 is 2. Then you can cube this, and then you get 8. And you certainly don't have to write this in so many steps. I just wanted to really be obnoxious about that negative not being part of this process whatsoever. Okay? No calculator. All right. I'm not sure what she wanted on this even and odd roots. I think it has something to do with variables, though. So we will talk about this. You got to be careful. And I know we know numbers, but when we get variables, let's say we had x squared and we square rooted it. There is a problem with this. First of all, I hope you know that the square root of x squared is a free x, and that's all good. But remember, in the real number world, say x happened to be a negative number. And I guess this is the best way I can. I'm sure I'm going to be doing this mathematically wrong. That's some math person that's really a stickler. But what you have to understand is, say you squared that negative number and got a positive, and then you square root it. This would have to be a positive output value. So you need to associate that with variables by putting an absolute value on this. And here is the rule, and I'm just going to teach it as a rule, and you have to have it memorized. Whenever you have an even root and an odd power results in your answer, you need absolute value. Why wouldn't you need it for square root of x to the fourth? I wouldn't be mad if you did it, but the square root of x to the fourth is x squared. If x was a negative number, what happens when it gets squared? It's a positive. So I don't need an absolute value there. The positivity of the answer is actually intact. When you have odd roots, it doesn't matter. The cube root of x cubed, of course, I hope you know that is a free x. And I hope you know that the cube root of negatives are negatives. The cube root of positives are positives based off of the last day in this part of the notes talking about cube roots up in the notes earlier. So you never need an absolute value when you have an odd index of a radical. I don't have to show anything else. That's it. Doesn't matter. What if it was cube root of x to the sixth? So that becomes, believe it or not, that becomes x squared. And I hope you pick this up real quick with variables. This is math 101 on breaking things out here. There's an x cubed and there's another x cubed. X cubed times x cubed is x to the sixth. This is a free x. This is a free x. So that's x squared. Same thing with this one. This is x squared times x squared. So the perfect square of x to the fourth is x squared. But the whole point of this is this is the one condition with variables that you must be aware of. Now, when you go into your book and look at the answers, in the book, they don't do this absolute value thing, but it is a thing. The book is a little too simple sometimes. Okay, so first question, don't have to worry about it. It's a fifth root. So what you do is you break this down. Fifth root of 32, fifth root of m to the 15th. Right, Jaja. Okay, and then hopefully you end up getting this pretty quick here. And you can split this up into two radicals. First of all, we already talked about fifth root of 32 is a number 2. Now, what times what times what? Okay, that's the way I'm going to break this down. So for a fifth root, you need something times itself 5 times. So let's write this over here. Fifth root of m to the 5th. Hopefully you understand that these are opposite operations and that's an m. And no absolute value needed because it's an odd index. If m is a negative number, it will be negative. Fifth root of a negative is a negative. That's what's behind all of this. But how many m to the 5th do I have? There's 3 of them. So you hopefully understand that this becomes an m to the 3rd free out of this. Maybe I'll write it as this being your first time seeing this. Okay, so you get 2, and then maybe you want to think of this as fifth root of m to the 5th, another m to the 5th, and you can split this up into 3 different radicals. And we're implying that you know about multiplying powers. You add these exponents, 5, 10, 15, m, m, m. 2 m to the 3rd is free out of that radical, simplified. And then hopefully you could see real quick, 15 divided by 5 is 3. So the fourth root, uh-oh, This is a fourth root. I might have to worry about absolute values. Let's see what the answers end up becoming. To the 20th. So real quick, this is x to the fourth. You will never do this again, by the way. X to the fourth, x to the fourth, x to the fourth, x to the fourth. That's x to the 20th. And then y to the eighth is y to the fourth, y to the fourth. The fourth root of x to the fourth is x, 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 x. 5x's multiplied together is x to the fifth free. Or you probably could have just divided 20 divided by 4 if it's divisible. And as of right now, in the beginning stages of your life, that we're having fumble questions that's going to happen. And then fourth root of y to the fourth is y squared freedom. Okay, you try and then see what we got. Some solving. I got to hurry up. My wife's calling. She's mad at me. Cube root of -8. There's the bell. Cube root of 8 to the third. A. Cube root of b to the ninth. B to the third. Because b to the third times b to the third times b to the third equals b to the ninth. For every b to the third, a b comes out free. I really just divided. Fourth root of 256. Ooh, 256 is 16 squared. So 16 is 4 times 4. This is 4 4s multiplied together. The fourth root of 256 is 4. Fourth root of x to the 12th. 12 divided by 4, 3. 24 divided by 4, 6. Really hope you know the reason why, though. Yes, this actually works out going fast. We'll talk more about that. 4-2 has a lot of the same questions, and things don't work out so nicely, so we're going to have to talk about that even more. Ooh, did I make a mistake? Did I need any absolute values? I did. What a bum. Even index, odd power. Okay, I think I should have it around the third. Oh, no, that's not. Yeah, that is true. Get that back there. Even index, but even power. Don't need the absolute value. Even index, odd power resulted. So that has to be a positive output value. That needs to be insured in that. That's something else we'll probably have to kind of shimmy down here for you to make up a word there. X to the fifth equals 32. And then how do I solve this? Whatever I do to one side, you do to the other. This becomes x, and then lo and behold, the fifth root of 32 is 2. Divide by 2 first. X to the fourth equals 64. Is that right? 60, 128. Oh, no. I don't know if this is perfect or not. I think we made a mistake because this is a perfect 8 times 8 is 64. Is it a perfect fourth power too? 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. 6. No, you know what? This ends up being, what's a perfect fourth root in here? 16. Okay, so 64 is 16 times another 4. Oh, you're going to hate this. So when we're doing this solving, this is the fourth root of 16 times the fourth root of 4 left over. So this one, I think we made a little mistake, but this leaks into 4-2, what we have to do with this. The fourth root of 16 is 2. The fourth root of 4 does not simplify. And I know this is going to blow your mind. Looks like something should happen there, and it doesn't. Divide by 5. X cubed equals, oh no, 32, 64. Well, that one's better. Perfect cube of 64 is 4, not 8. 4 times 4 times 4 is 64. Then don't forget on square roots. I think that's 81. When you do a fourth root, there are 2 possibilities that work. It is plus minus 3. The reason is -3 times -3 times -3 times -3 also equals 81. So anytime you have to even index both sides in solving, just like square rooting, which some of us still to this day have not written a plus minus when they solve by square roots. Heck, some of you still don't know how to solve with using square roots, and I don't know what's going on with you. That last test that we had, just get on board, man. There's some craziness going on in this honors math class. All right, so we got to get the job done here. But anyway, notice we didn't have any plus minuses on the cubes and the fifth roots. Oh, I'm a maroon. Speed kills sometimes. Fourth roots plus minus. That should have had a plus minus as well because same reason as x squareds when you're solving x squareds. Two possible answers. Okay, that's good enough. I got to go. My wife's going to kill me.